Good afternoon, everyone. Welcome to the session now on the Introduction to Dynamic Routing. I'm Brian Horn from Winters Broadband, and we also have Matt and Tim here in the front row. They'll be saying something a little bit later and answering Q&A as well. The reason we're all down here on the floor is if we sit up there, we can't see the screen. So they can't see what I say or what the slides say. So that's why we're all down here for the moment. The subject came to us from the Agenda Committee, and they asked us to do a very specific introduction to dynamic routing. Not telling you how to do it, but what it is. How many people here, by show of hands, have implemented OSPF? Oh, okay. So I hope we can teach you something still, but let's see. So we took a look at dynamic routing and took two definitions as to what it was. One from Technopedia. So it's a routing technique that provides optimal data routing. Unlike static routing, dynamic routing enables routers to select paths according to real-time logical network layout changes. That really is what OSPF provides for you. And in the internet side of it, BGP. And then there's a second definition there from Wikipedia. It's a process where a router can forward data by a different route or given destination based on the current conditions of communication circuits within a system. So we can take a look at this in a little more detail from the actual theory side of it, and we'll give you some references at the end where you can get more technical detail with regard to implementation and configuration. So if we look at IP addressing, what we find today is with many routers, many WISPs, you've got a block of addresses that have been assigned to you by the carrier. And so you have a limited number, typically a /24, and then what you do is you give some of those out to customers as IP addresses as public ones. The others you would NAT, and then use NAT to provide private IP addresses in your network. If you are more established and have managed to get IP address blocks from Aaron, then you would be multi-homed, as part of the requirement. You'd have your own AS number, and we'll get to what ASs are, and you'd have your own block of addresses. You may also have IPv6 address block, that's there. And the protocol you'd be using between your router and your data center and the internet would be BGP. Sorry, the smoking, I'm allergic to it, so it's finally got to me in the hotel. The thing with the IP address blocks nowadays, if you're starting up from scratch, you can get a limited allocation of IPv4 addresses to work with an IPv6 address block from Aaron. If you don't have, the only other place you're going to get addresses at this point in time is go to like IPv4 auctions and buy an address block there. And yeah, what happened in the beginning, people asked for addresses, they really exaggerated what they needed, and you get large companies, some of the large companies in the US nowadays, found they got a large blocks of addresses and they're selling them off at a pretty big, hefty price. I just bought a /22, it cost me just over $14,000 for that. So what happens inside your actual WISP network now? One of the things that a lot of WISPs do is they edge routed. So that is the devices at the edge, the CPE is in a router mode. So you're protecting your network, you're not bridging your customer into your network. If you do that, and if you're still doing that, believe me, that's one of the first things you need to fix very quickly. Hopefully nobody is doing that. But what happens in that big network of yours is the thing, and this is where you need to look at putting routing in. I can tell you I know of one WISP that has grown to 600 to 700 customers at the moment. He still has a bridge network in there. And he calls and asks for help on occasion. And he says, I see all this traffic moving here. Where is it? Where's it coming from? Well, that's your traffic. It's just moving around your network. There's no control in it. It's all bridged. So what the ideal situation to get to is a fully routed network. So routing at the edge and fully routed inside. So looking at dynamic routing, the benefits are you don't have to maintain the routing tables. All you have to do is take a simple network, put it together with a few routers on a bench, and try and figure out the number of static routes you have to put in to make that work. And you soon realize that it doesn't scale very well. You have to go to dynamic routing. So what the network does once you've gone to dynamic routing, it can compensate for losses. This can be loss of a node. This is where you've lost a tower site. But it doesn't have to be a tower site that you lose, for example. It can just be the link between. So you've got a point-to-point link, maybe air fiber, maybe just nanobridges, AP and a CPE. But you lose one of those, and you effectively lost something in your network. So it can take care of that. So the protocols in dynamic routing, there are a number of protocols there, but what we're going to look at is OSPF. It's the most widely used of the protocols in WISP environments. If you're still using RIP, it's time to move on to something a little more modern. So if we look at OSPF, what we really have is we have active paths or active links in the network, and we have backup links. So the active links are where we're moving our data, and as you can see it, there we go. So this is the route to site 1, the route to site 3, and this is the route to site 2. These may be decided by where you can put towers, the actual quality of the link you can get between them, and the location. So geographically, it may not make much sense the way they are there, but this one, for example, could be a much lower bandwidth, and that's all you can get on that link, unless you put up some really a high tower or something. But at least you've got backup paths. So the first thing with regard to looking at routing, we have the concept of an autonomous system. This is a collection of routers in a network that are seen as one entity. So in this case, we're taking OSPF, and they're just seen as one group to the rest of the network. It's invisible to the rest of the network that's out there. And so they get an AS number that's defined for the group. So now, if you were registered with Aaron, and you had a BGP, you would have got an AS number from Aaron. If you got one years ago, it would have been in the range of 0 to 65,000. They didn't think it would ever get that many networks in the world. Then what happened is, of course, like with IPv4 and IPv6, something had to be done. So they came out with the 32-bit version. That took us up to enough to take care of everything there. The usable range is actually 1 to 64,511. The 512 to 535 range is for private use. So if you're creating your own AS that's not registered with Aaron, you'd go use an address in that range. And the way they took care of expanding the AS numbers was it becomes 1 point, whatever the number is, if you have to go above the 65,000. The next thing we have with regard to dynamic routing and OSPF is the concept of areas. And areas are groups of routers. And you can have, one thing with a bit of qualifier up front is any of the bits that I say relate to Microtech, which I think is the most commonly used router amongst us. And so if the numbers are slightly different, because you're using some other manufacturer, anything I say, read Microtech in fine print. So in that, typically you can have up to 80 routers in a group or in an area. So the structure of that area is invisible from outside the area, and each of the areas that you have run a separate instance of what's called a link state algorithm. And each of the areas is identified by a number, which is in the same way as an IP address number, from 4 zeros to 4 255s. Now, I've seen OSPF networks where people think each site has to be an area. You're just making life very complicated for yourself. Until you grow quite large, and you're a smaller WISP, you don't need multiple areas. There has to be a backbone area. It's the core of the OSPF network, and that's area 0, or 0.0.0.0, the 4 zeros. And it's responsible for distributing information between non-backbone areas. So if you have more than one area, the other areas have to connect to the backbone area. The backbone area is responsible for distributing the data between the areas. And that can be either directly connected, as I'll show you, or through virtual links. So here we have the backbone area. It's connected to the internet. Here we have area 3, which is directly connected to area 0, which it has to be, and area 55, and it's connected by a virtual link. So it has to be connected back to area 0. We also have some other types of areas called stub area, which is only one connection into the rest of the network. We also have things called not so stubby areas, and those are ones that can inject routes. But I'm not going to get into any detail on these because those are not things you're going to have to worry about in a hurry, but they are there, and if you get to advanced stages, you'll be looking at those sorts of things. But we'll focus mainly on what happens with area 0. So the other thing we have is, and these are terms that you're going to see come up everywhere, is the router types. So we have ASBRs, and I'll get what they are in a minute, ABRs, and IRs. These are autonomous system border routers. So these are where they're between the OSPF area, between two different types of area. So this is BGP to OSPF, and this is injecting routes into the backbone area. The area border routers, the ABRs, are between two areas. ABR there, ABR over here. And that injects the routes from the other area. Now, each of the routers maintains a table of what the routes are, the link states from the link state information, but the area border routers have to maintain 2 sets, one for each area. When you go to like this not so stubby area down here, that's an ASBR because it's bringing external routes in, so it's between 2 different types of area there. So here are the 3 router types: the ASBR, the Autonomous System Border Router. Normally you'd have 1 or 2 of those. In a typical WISP, you're going to have, those are the ones that are going to connect you back to the internet, back to your BGP, back to your service provider. And the reason I say 2, redundancy, because this is where you have redundant connections into the internet. So it's a router that's connected to more than one AS. It acts as a gateway between OSPF and other routing protocols. And it distributes routes received from other ASs throughout its AS. The area border router is connected to more than one OSPF area. So it could connect to 2 or 3, because all you're looking at is the interfaces on your router. You're putting an interface into one area or another. And the ABR keeps track of multiple copies of the link state database, because it has to keep for both sides, for each area that's connected to. The IRs are just internal routers that are within an area. So the OSPF works on what's called link state advertisements. This is how it communicates inside the OSPF protocol. It communicates its routing topology to all the other routers in the OSPF area using LSAs. And the link state is gathered from the OSP routers and it creates a topology map. So the way it works, there are a number of link states, LSA types. Type 1 is the router one. This is where the routers start telling each other, I'm here, and this is my information. The network ones, LSAs, type 2s, are the ones where the what's called the designated router, which is actually running and managing your OSPF network, it's the one that's sending it out. So typically in the network that you have that's OSPF, you've got LSA 1s and 2s that are moving between the routers there, either coming from router to router or the routers to the designated router, which is managing it. And we'll get to that. The other types are used by ABRs or ASBRs or NSSAs. So, but this a lot more detail than you need to worry about at this stage, and most people never actually get near worrying about it ever. I think it's really advanced stuff. So the link state, OSPF uses the link states and a thing called Dijkstra algorithm to build and calculate the shortest path to get to a destination in the network. And one thing to note is that OSPF uses IP protocol 89 for communication. So if you put OSPF in and something doesn't work, just make sure that you're not blocking that in your firewalls or something, because this is where the protocol that's used there. So it distributes information, OSPF distributes information within a single AS. So if we take a look at the way the algorithm works, it looks for the shortest path between two nodes. So when you go configure routers, what you do is on each of the interfaces, you go assign a cost. And that cost is how you determine which way the traffic's going to go. So this is one of the bits that you have to do along the line and when you plan your network, and it's the one thing you will end up changing when one link becomes a higher bandwidth than the other, and you have to optimize your network. So if we assume those are the costs that have been assigned to each of these links, and the cost is assigned at both ends of the link. So the interface here on the router and the interface there on the router get assigned a cost. So what happens is if we take a look at this path through the network, it adds up so we're going from router 5 to 3 to 4 up to 1, and if you add up the cost becomes 26 there. 26, if I can see right. So that's the cost for that route. So if we're trying to get from this PC to that server, we got multiple routes there. So that one was 26, this one's 28. So you go through, add up the costs, you get the cost of your route that's going to take to go through the network. We have another one here, 9, 11, 20. So if you take all of the routes into consideration and you figure out all the costs, you now end up with this scenario. What will then happen for OSPF, it will choose the route with the lowest cost. So it's gone and taken this route because 20, if you look through all the costs that came to there, 20 was the lowest. So that's the route that traffic takes through your network at that time. If now that link fails, that one there, automatically OSPF then recalculates and recovers from that. And it normally happens well within 20 seconds, your recovery time. And what it does is it's going to switch to the next cost. So it looked at which is the next lowest cost there, figured out that that's the best route to get there. If you look at this, your network actually, all of your devices still in the network are running. You still have links to all the sites. If we now have another failure, so that one fails, it now reroutes this way. It's going to take the next lowest cost of the routes through the network. And this is exactly how OSPF works. So it's important, the important bit there is when you lay out your network and you plan it, is you plan the costs. You know, you calculate what costs you need, so you optimize the traffic to go the way you want. Interface cost, the default cost is 10. You override it by going into the interface, the entry in the interface, and edit the entry. In fact, what you do is you can't edit it. I'm talking about a MikroTik router. Now you'll see the entry in there. You'll see it's put in dynamically. It has a D as dynamic. You copy it, you change the cost, you say apply, and it creates a new entry, replaces the dynamically created one, and you've got a static entry there. And the cost can be anything from 2 to 65,000, or 0 to 65,000. One of the important parts of the OSPF is the designated router. It's the single source for all the routing updates for OSPF. So it maintains a complete topology table of the network, and it sends updates out to the other routers. So when one of those links failed, OSPF detect the routers report that back to the designated router. The designated router then recalculates and informs the routers of the routes that get taken. The router with the highest priority is elected as the designated router. So if you don't do anything to choose which ones get elected, they will go through an election process themselves. And the router with the next highest priority is designated the backup router, BDR. So you have a primary and a backup one. If the DR fails, there'll be a new election process and 2 new devices will take over. So part of the settings that we have to set with regard to OSPF, we have a router ID, and that's got to be unique within the AS. We have to specify the networks where OSPF must look for the other routers. So this is where a network, you specify, and we'll get down to what they are in some drawing things in a minute. But for example, you'd say the network from site A to site B it's a /29 given the addresses, and you'd put the network in as an address there. You use exact networks, you don't aggregate. So it's not a good idea to just make one large, I've seen it done, where you have one large broadcast domain and /24 you're using. It's better to pin it down to /29s. You could do it as /30s, because you only need 2 addresses for the routers, but you do have 2 other devices in the link. You have, typically as WISP, you have 2 AP and a CPE, so /29 is a bit better. The other bit you have to choose is the network type, and you've got 4 choices here. Broadcast, NMBA, non-broadcast, multiple access, point-to-point, or point-to-multipoint. So the broadcast one is suitable for Ethernet and other multicast capable network types. NMBA is packets are sent to neighbors, they're unicast addresses. And if we look at the table, it gives you a bit better idea here. If we look at the interface type, designated router and the backup designated router, dynamic discovery of neighbors, and can you have more than 2 routers? Well, broadcast, it's yes all the way. NMBA, there's no dynamic discovery of neighbors. Not suggested you use it unless you want to create work for yourself. Point-to-point, no backup router there. It does dynamically discover the other side, but you can't have more than 2 routers. So that's just in a point-to-point configuration. This is the one that's really the one for point-to-point or point-to-multipoint, but in a point-to-point environment where you don't need the backup and the designated router because you just got 2 devices in the link. So as a WISP, you can either use PMP, point-to-multipoint, or you can use broadcast. The 2 options you have there. And I'm sure some of my colleagues will give you some other input as we go along. The other thing we have is that you're going to see in documentation, and when you look at things, is the route types. So external routes, for example, BGP. Intra-area routes are the ones inside an area, and you get inter-area routes, which are the ones which go between areas. So the route distribution, so when you have a router that's, whichever router you choose in your network, you have route distribution options. And the only one that you would normally redistribute default routes on is your main router, the one where you come in from outside, because it's the one that's really got the default routes. So on your data center routers, you'd have the default routes. Then depending on how you're structuring your network, you might just use connected routes. The devices that connect to that router, you redistribute that information. You have the option of also many other things that you can choose there. But we use slash, in our network, we use /32 addressing, and we just use default and connected routes. The others may have some other experiences to share. When it comes to redistribution settings, this is where it can get a little, some of the nomenclature and get a little bit confusing. But with default route, you've got 5 options. So you can either never redistribute it, can redistribute it if it's installed, or you can always redistribute it. If you choose always redistribute it, say on a data center router, you then have 2 options, as type 1 or as type 2. So these are metrics basing the decision on whether you take into account only your internal network or your external network as well. So typically, we use type 1, and I think most people use type 1. We'll see what the others do. But I'll show you how those metrics are made up in a minute so you understand them. When it comes to the connected static, BGP, etc. routes, if you want to redistribute those, you have the type 1 or 2 option once again, or you have the option not to redistribute them. So you can decide not to just redistribute. The way the metrics work, so this is external type 1. What happens here is we're going from the internet out to this site here. The cost on the link, the BGP link here is 8, and then we have a cost of 10 from data center to site 1, and a cost of 10 from 1 to 3. So our cost for that route is 28. So that's type 1 metric, that's how that's calculated. If you use type 2 metric, it only takes this into account. It ignores what's happening internally in your network. So that's how you make your decision. So typically, one ends up using type 1 metrics. That's what we do. Type 2 is, that's to explain it to you. When it comes to routes, there has to be a priority order in which they selected. And so OSPF chooses routes in the following order: the intra-area first, so those are ones inside its area, it's going to use those first. Then it's going to look at inter-area ones. Then it's going to look at external type 1 or 2, and then get into not so stubby ones. But these are things that, just letting you know they're there, they're not things you normally have to get into doing. They just be aware of them. It could be that if you end up with some situation where there's a problem, you might have to look at that. You can also apply routing filters. These can be applied to incoming and outgoing OSPF messages. So the routing filters only manage external OSPF routes. Once again, if you've got multiple areas, this is where you'll be looking at possibly doing something there. If you're in one area, you wouldn't be doing something there on that side at all. So OSPF benefits, you get automatic propagation of the routes in your network, and you get the failover to improve your reliability and resilience of the network. We were asked not to cover detailed configuration, so we didn't. But 2 years ago, there was a session at WISPAPALOOZA in great detail on basic routing with OSPF. And if you need information on that, that's what to look for. If you can't find it anywhere, just drop me an email and I'll certainly be quite happy to send you a copy. But in that we got into the actual configuration. We didn't get into the background information, but it was a case of how do you configure it and make it work. We used, I think it was a 3-node network in the example that was used there. Some tips. One thing is you have to create a router ID. So a good idea there is to create a loopback bridge and give it an IP address that you use to access the router. Use that same IP address as the router ID. So you've got that taken care of. Securing your network, you don't have to do it initially, but it's something that's add-on to it, is authentication keys you can put in on all the links. Remember that if you put a high priority for the highest priority that's available there is 255 for the designated router. So you can then set which one will be the designated router, typically one of your data center routers there. And then use the correct network types. And that's a really important part of it. To increase performance, use the correct area types. Typically, unless you're getting bigger, you'll only end up with one area, so that's pretty simple. And you can use route aggregation. This is just a little bit of tell you how we do things on this, is if you take 3 nodes, so we got data center site 0, we say this is tower site 1 and tower site 2, it can get pretty complicated as to what your addressing scheme is that you're using for OSPF. So you can make it quite easy, is if you decided on 10.10, or if you decided on 172.16 or whatever other private address you decide on, what you can quite easily do is what we do is we give sites a number and a code, normally 3 alphabetic code and a number. So it makes it really easy to know what they are. So if this is site 1, this is site 2, and this is site 3, this link number becomes the lowest of the 2. 1, 0, so this becomes link 1. This is 2 to 0. 0 is already used. We use 2 for this one. And since this one, 2, 1, we can use 1. So you got 10.10.0, 10.10.1, 10.10.2. So they're related to your sites. What we then do is the routers are .1 and .2. Or I'll show you something else on the next slide that you can do. So you can use a /29 for that. If you've got the wireless link in there, which most of us have between the two, say if this was link, you've said this is link 0, you got 10.10.0.1, .2 is your AP, .3 is the station side, and .4 is your router on the other end. You've got 2 other addresses you can use, 5 and 6. So for test things, you've got those that you can use there. The thing to remember with this is that it'll be advertised from this side. If you advertise a network, you don't want to advertise both ends of a link, because if you do, and you've got your management software, and you lose the link, it'll still say this one locks up, but it'll still ping. You'll still see the other end there. But if it's being monitored from one side in the network, it does the checks this way, and it reports that everything's up. With regard to IPv6, if you're looking at moving that direction or implementing IPv6, you can get allocations from Aaron. I don't know how much they gave you at the presentation here, but certainly if you don't have an IPv4 allocation, you can get a limited one and an IPv6 block. So if I did a presentation in Denver a few months ago, and it's on the Microtep Mum site, and I got into detail there. I gave all the details of working with Aaron, how to get those address blocks, and what it would cost you, etc. When it comes to doing IPv6, Microtech, it's really simple. The IPv6 package is loaded by default in the software, but it's disabled. So all you have to do is go in and enable the IPv6 package and reboot your router, and you're IPv6 capable. And then with what it runs is OSPF version 3. So you're running 2 OSPF versions, 2 for the IPv4 and 3 for IPv6. But it's much, much simpler in IPv6 than in IPv4. And then of course with BGP, you just have to advertise your, the blocks that you've been assigned. So I'm going to hand it over to Matt, and Matt's going to fill in all the bits that I missed.
Thanks, Brian, for that. That was really informative. Got a chair there. So yeah, I just wanted to add a few examples or pointers from our implementation of OSPF. We implemented OSPF probably 3 or 4 years ago. And some of my notes are, Brian also already went over, but I would definitely highlight, that by default, these are not in MikroTik. It's not password protected. You definitely want to do that. We right now just do one area, and we are looking to move to multiple areas probably within the next 12 months, 12 to 18 months. And Brian already went over this as well, but just want to highlight it. Ethernet links, you can leave on the default broadcast type, but wireless links you definitely want to set to that point to multi-point. And then there were some links to the specific MikroTik configuration in Brian's presentation. And then just a few other things. I know that several years ago, the OSPF implementation in MikroTik was badly broken, and that got a really bad, MikroTik got a really bad rap for that. And I think a lot of people still kind of feel that way and try to get around it and not use OSPF with MikroTik. I can tell you that as long as you're on one of the current versions of MikroTik, it's solid. We've been using, as I said, for a couple years and had some trouble in the beginning, but that's kind of worked itself out. And so make sure that all of those versions of the routers that are connected with MikroTik are the same version. You don't want to try to mix and match versions. And then also make sure the clocks are using the same source. That's all very important.
One thing that struck me originally, multi-area OSPF is definitely an interesting thing to know about. But just to throw this out there for people who have not done OSPF, our WISP, we have about 6,000 customers, and we have a single area. So it's not something that you would probably need to be doing anytime soon. There may be little interesting things you could do with it to solve certain routing problems, but those would be edge cases. Like day-to-day operations, just stick with one area and your life will be a lot easier. One other thing that popped up in my mind was OSPF is what's called an IGP, an Interior Gateway Protocol, and it's really just for you. If you ever have a customer who says, hey, we want to, we've got a block of IP addresses, we'd like to talk OSPF with you to announce those to you, like, no. There's no reason that any ISP should ever talk OSPF with a customer. Very bad things can happen. Brian was talking about, originating default route. If your customer flips the wrong switch and starts sending you a default route, well, now you're sending your internet traffic to your customer. So yeah, don't do that. And that can be fixed. One of the configurations in OSPF is it's a network list. Which IP networks that are configured. If I'm a router, I look at this list. I've got a bunch of networks on different network interfaces, and which block of or blocks of IP addresses will I discover or speak OSPF with a peer, with a neighbor. And so your customer routes should never be in that network list. You never want to open yourself up to that. Another way around that is using encryption, but it's always good to have layers of security and not just say, well, we turn encryption. Yes, we enable OSPF on all of our interfaces, but we of course always enable passwords, well, until at one time you don't, right? A couple of other things that popped in my mind is the costing structure on a link. Brian was showing the cost of the link kind of in the middle between the two routers, but it is always configured on each link, on each router of that link. And you can misconfigure things and have a cost of 10 on one router, facing on router A pointing to router B, and a cost of 50 going the other direction. And at the best, that can cause asymmetric routing. Well, at the best, it might not do anything, but it could cause asymmetric routing where traffic to router B will, from your internet edge, will take one path and traffic back will take another. At a worst, your traffic will ping pong back between those two routers because router A says, I need to send it to router B as my shortest path, and router B says, well, my way to get to router C is to go back to router A. So always make sure that your costs are set the same. And regarding costs, MikroTik doesn't do bandwidth-based costing, does it? Is it just 10 by default, regardless of whether it's, okay. Many other router manufacturers will look at the link speed. If it's a 10 meg Ethernet circuit and it came up, it'll do a cost of 100. And if it's a 100 meg circuit, it'll give it a cost of 10. And if it's a gigabit, it'll give it a cost of 1. And on those manufacturers, you can often set what the default is. So in this case, the cost of 1 is a gigabit. We have a 10 gig core, so our cost of 1 is a 10 gigabit Ethernet interface across our entire network. If it's a gigabit interface with the radio, it then gets a cost of 10. And you can often, I know Ubiquiti to do this, we're a Juniper shop also, you can on an interface say, well, this radio, yes, it's a gigabit interface, but really the link quality across this is, we're only getting a capacity of about 400 meg. So you can do manual, instead of a manual cost, you can set a manual bandwidth on there and say, this link is only capable of 400 meg, and then it'll figure out the OSPF cost. If you change your kind of baseline cost, it'll recalculate that, that bandwidth cost for you. What other things do I have on here? Oh, and asymmetric costs. When a link fails, there's two things that can happen, two ways that your whole network will recalculate the costs and the best paths. If the link actually goes down, like a cable is unplugged, your router immediately knows something went wrong, and it can send messages and say, we all need to get together and recalculate, let's do it right now. And that's a pretty good thing. You kind of want that to happen as soon as you can. But if it's a wireless link and you have rain fade or something like that, well, now there are these hello messages going back and forth. Your routers are constantly saying, hey, you there? Yeah, I'm here. You're there? Okay. And then when the link goes down, but the Ethernet is up, but the microwave goes down, you have to wait for those enough failed hellos. It's like one router will say, hello, I didn't get a response. Let me try again, hello, didn't get a response. And that's where 30 seconds later, it's like, I'm giving up. I didn't hear from my neighbor. We've got to recalculate, guys. This was enough of a problem for the WISP community that Ubiquiti added a feature to their air fibers that if they lose their microwave link, they'll actually they can take the Ethernet interface down to force that recalculation so that it can take a second path. So that's something to keep in mind. Another way to get around that is a protocol called BFD, where you're sending basically a flood of traffic all the time across. It's like every couple of milliseconds, it's sending a tiny, are you there, and I think that'll do link detection or it's like 100 milliseconds or something like that. Yeah, to be honest, I've never played around with BFD, but I just know it's there. But it's worth looking into if you've got a lab and you're setting this up for the first time. Yeah, play around with it. And then the last thing, Brian had mentioned putting a loopback interface on. That is very important for a lot of this stuff. I've seen a lot of WISPs that will just let the router decide its own router ID based on the lowest IP address that's configured on any interface. And it'll work. But having a router ID, a consistent one, you're looking at the tables, it's not doing a reverse DNS or anything on that IP address. If you configure a loopback IP, which is kind of its identity, that's its real name, right? And that will then show up in your OSPF tables as like, this is who I'm talking to on this IP address on this interface. And having a loopback IP for management is really important because if you're always connecting to the IP address that's on Ethernet interface 2, for example, but you've got a backup path into there, if that radio that's plugged into Ethernet 2 goes down, usually, and this is the right behavior, the router will stop listening on that IP address and it'll stop advertising that over OSPF. And now you have to remember another IP address for it that's on on that other interface. If you're using loopback all the time, that loopback interface is always up, regardless of the state of any of the other interfaces on that router. And when you get to doing, if you become larger and you want to, there are more complex network dynamic routing methods where you have OSPF with internal BGP running on top of that. And when you do that, you always want to use your loopback address as kind of the final destination. Router B will say, in order to get to these customer routes, you need to send it to my loopback address. And then OSPF is used. Now, how do I get to that loopback address? And then it looks again in the table and says, okay, here's the shortest path to get to that loopback address. So loopback's good network practice on your networks when setting it up.
So I think we'll take questions. They are trying to record these sessions, so there's a microphone there. If you'll use that, that'd be appreciated. Any questions? Some coming up? Good. One thing with people just getting there, is if, as Tim said, the rain fade, but your performance on a link goes down, the performance goes down, but it doesn't drop out completely, you do have the issue then that link will stay running. It's not going to be seen as failed. So you'd have to look carefully at that time of the year what's happening. Yep, please go ahead.
You said that use...
I think it may not be turned on.
You were saying that about 80 routers per area is about the max you want to do. What happens if you use more than that?
I don't think there's anything in the protocol that has that number of routers. Is that mostly just because Microtik's OSPF?
Yeah, there's no limit in it that stops it working. It's just a recommended that that's a good number to keep in there to keep everything working optimally.
Among larger broadband providers, I've kind of heard, like with Cisco, Juniper, Brocade class gear, the amount of messages that start getting sent around when things get recalculated is really around like 2,000 or 3,000 routers is where the big where kind of the largish, in our world, that's a large network. But when they're really going into like larger regions of the United States, that's where they would start to go with an inter-area or multi-area OSPF.
And I would just add to that, with Microtik, it has a lot to do with what type of router. So if you're doing a higher-end cloud core, it's going to be a lot larger number than that.
Thank you.
The cloud core can handle more
I
routers.
don't know. I'm not going to say a number, but it's a lot more than 80.
Gotcha.
Yeah, every time it recalculates, it's a big CPU hit on on all of your routers, because they've got to go through this algorithm and they've got to find. It's not just as Brian was showing. It's not just calculating the shortest path from your border to all of the routers. Each router is figuring out the shortest path from them to every other router on your network. So they're all crunching numbers. Everyone has their own different view of the best way to get to any other router.
I wanted to add something. If two OSPF paths have the exact same cost, Microtik will split the traffic about 50-50 between them. So it's sort of like a poor man's link aggregation that can go through completely different paths in your network, which is kind of neat.
Yep, and it'll do that per connection. It wouldn't it's not per packet. So traffic from customer A to Google's website will always follow that same path. But if customer A is talking to Netflix, it might take a different path.
Yeah, that's good to make sure packets arrive in the same order.
Yes.
Yeah, it's done on a per connection basis called ECMP.
I had a question too. A lot of the time, our tower crew wants to work on a radio in the middle of the day, and so I will take traffic off that link by setting the OSPF costs very high. Normally they're at 10. If I set it to 100, that takes all traffic off that link. But while it's recalculating, things will still try to send traffic on that link, and it causes a few seconds of downtime. And I'm wondering if there's any way to take a link down in OSPF without causing any downtime.
The only way that I've seen this done in Juniper, it actually does backup cost calculations for it. Kind of goes through different scenarios. If this link fails, I'm gonna pre-calculate backup costs, but you don't see that in Microtik or Ubiquity.
Also, this BFD feature sounds really interesting. Has anyone in the room tried that? How does it work?
We use it, and we just tell our guys to take down the link and take it down, and all traffic goes the other way.
Awesome. I'll give it a shot. Thanks.
You can run BFD for BGP as well within your network.
I know you said that areas are probably not useful for most people, but I'm not familiar with OSPF, but I'm pretty familiar with a routing protocol called Babel, and Babel has routers advertise subnets. So you can advertise a subnet net, which means you can get traffic to routers in that subnet. So I was wondering why OSPF has the concept of areas, which is separate from subnets.
No, OSPF is using subnets. So if you're at a tower site, you will be advertising or listing what you want to be redistributed or connected there. But the area is just the management concept that the OSPF group of routers is managed in.
Yeah, say you've got offices in Chicago and San Jose, and they're fairly large networks. You can, instead of when a router, like an interface changes in San Jose, do you really want your Chicago routers recalculating their best routes? Right? You may just have 2 routers connecting those 2 regions. So you summarize all of the routes on that border, and you let San Jose take care of its best path, and then those summary routers that are connecting the 2 areas will just say, yeah, I know how to get to that. Like I'm not going to tell you that link way over there failed.
Thank you.
Right towards the beginning, you mentioned having CPEs in router mode rather than bridge mode, and if they are in bridge mode, you need to fix that right away. What's kind of the reasoning behind that?
Well, we're talking about the customer CPE, right?
Right.
So at the customer site, if the last thing if you have the router, the CPE in bridge mode, you better have a router behind it. If you don't, and it's a customer router, and they play around with the cables, and they plug it into one of the LAN ports instead, they're going to be injecting stuff back into your network and offering DHCP services, for example. It's just, anything can happen when that happens there.
There are ways around that, though.
Oh, yeah.
We do our CPEs in bridge mode. All customer traffic is separated onto its own layer 2 VLAN with other customers, so they are not on the same broadcast domain as their CPE radio. And then you can turn off the ability for customers to broadcast traffic to other customers. You can configure most CPE equipment to basically firewall off any DHCP messages any DHCP server messages originating from a customer. And Cambium has the ability to limit the number of MAC addresses that will be responded to in the bridging table as it goes up. So you can limit it to 1, and if they switch it in wrong, well, the first device that it saw will be in the bridging table, and their TV isn't going to get an IP address, and all their other stuff is going to be able to get IP addresses. So there's other network management practices that can go. I always think of our WISP network. My goal is to bring it as close to the way that the wireline broadband providers set up their networks. And so that I'm a big proponent of giving public IPs directly to customers and doing as little NAT as possible. Now that's becoming harder and harder over the years, as the years are going to go on. And especially you in the room who probably don't have easy access to IPv4 addresses, you're going to have to take hacks, and you're going to have to probably implement IPv6 as fast as possible, and make that happy for your customers. But that's the way I always approach it.
Yeah.
And just I'll give our perspective. We do the CPE is the router, the local router. I think Brian's point there, though, was, if you're not doing routing in your core, if you're bridged and you're also bridged into your customer, you've got no control over that.
Yeah.
And so that's what you really need to fix ASAP. I think that's what you're saying.
I think the thing that I see is what we've always tried to do is keep it as simple as possible. There's all sorts of things you can do with all the routers at the tower sites and everything else. We have virtually no configuration in them other than OSPF that's running in them. All the firewalls and that stuff's done at the edge or at the data center.
Great. Thank you.
Thank you. Any other questions?
How do you assign the public IP to the router? If a customer wants a public IP and the CPE is in router mode, how do you assign a public IP to the router of the customer?
I understand that's how do we assign the public IPs to the customers. We did something unusual. It was a few years ago, and I've done a few presentations on it, and you'll find them on the MUM and normally. We were running out of IP addresses. And if you try subnetting at the towers, you get into more trouble than ever because we only had a certain number. And then you had this one tower site where all the addresses are used. You go 16 addresses, we go to 32. Now we suddenly got a lot that are not used there. So we actually went to /32 addressing. So in the CPE, it's given the /32 address. So public /32 address. So 1.2.3.4 has the public address in it. And the network is a different address. You can make the network address anything you want, in fact, but like 10.0.0.1. In the router that provisions that at the tower site, the IP address is 10.0.0.1 and the network is the opposite, the 1.2.3.4. And that way, 100% of our addresses are usable. We don't lose them in subnetting. But if it's something you're interested in, I can always provide you with more info on it.
Go ahead. No, I was just going to say we do it the poor man's way and one-to-one NAT. And then if the customer, I think what you're asking is if the customer has their own router and really wants an static IP on there, then we do bridge the CPE and it's a negotiation. We do PPPoE, and so we'll give them their PPPoE information and say, here you go, you can configure your router. And if they say, that's not what I wanted a static IP, we'll then work with them to do that. So there are steps that we do, our preferred method, and then we kind of go down the line.
Yeah. We have acquired several WISPs, and so everyone kind of starts with a different baseline. And so a lot of my answers are a little bit taken with some salt, which is like the preferred architecture, which, to be honest, doesn't really exist anywhere yet. It's where we're going to. We got all these different pieces of our network that we're trying to go into this one unified way. So some parts of our network are also doing one-to-one NAT with private IP addressing on the CPE, which is in router mode, and same thing. If they need an IP address, we put it in bridge mode, and hopefully you documented it well enough so that when their CPE gets replaced from a storm, that it gets set up the right way, and they're not calling, the guy left, I was on the internet, but my NAT isn't working, my public isn't working. So consistency is key, and that's what he's talking about. Like the less consistent you are, the more it can go wrong when you change things, and so. Other parts of our network, we are doing, customers buy a new router and plug it in. It's defaulted to do DHCP, and it does a DHCP request, and we hand them a public address that we have, assigned to that customer within our DHCP server. Cambium has some nice features where they tack on some special information where even if they change a router, the AP's MAC address and the station's MAC address is tacked on to that DHCP request, and you can use that as the key instead of using the router's own MAC address. So customer replaces a router or a technician plugs into that station, they'll still get the same public IP address. And if the customer has their router turned into a switch and their tablet is asking for an IP address from us, and then their television does, both of those devices will get the same public IP address, and then they're just screwing themselves over. They call us and it's like, nothing is working on my network. Well, that's because you got to switch, so fix that. So there's some, and Ubiquiti's adding that feature as well. It's called DHCP option 82. So we're looking forward to that because we rely heavily on option 82 with our Cambium network.
Yeah, on our customer side, we provide every customer with a managed router. We manage it, and so we control it completely. The only thing we do is there's no option anymore, and in fact, we now power the CPE from the router. So you get rid of the router, you got rid of your service. The only thing we do is we're prepared to put in bridge mode if you want to use your own Apple router or something like that. The only time that we actually allow the IP addresses to be put in a customer piece of equipment is on a business service, where you get some large corporation who've got their own IT department and all the rest. We still have a managed device, so we hand off on the site though, and then they connect to that. But it's just there for us to manage the service and monitor it. Good. Well, thank you very much, everyone, and I hope it was useful.